Morning.
Morning, everyone. Nice.
Welcome to Serverless for the Enterprise. I'm Matthew Henderson.
And I'm Jeff Holland.
We're both program managers on the Azure Functions team. Both been on the product for a little while now. We've got a lot of excellent content to go through here. We've actually presented together before. If we flash back to Ignite 2017, a whole year ago, we presented something that sounded kind of similar, at least from the title perspective, although the content was really different. And unfortunately, all memory of this presentation is lost to time because our projector went out and the recording failed. And so only people who were in the room where it happened actually know what secrets were divulged there.
And we will never, ever share them again.
They were all sworn to secrecy, everybody in that room. But today we think we've got some good stuff, so this is going to be our moment. We're actually going to have a redemption moment. And joking aside, there's a lot of good stuff in here, a lot of new stuff.
And we have prepared too. Matt and I have been rehearsing heavily, so if the projectors or the microphones do go out at any time of the presentation, just stay seated. We actually have a full 3-act play of all of our demos. So don't worry, we're ready this time. It's not going to be a failure. Redemption tour. Exactly.
So just a quick poll. How many folks are already familiar with serverless using Azure Functions, things like that? Okay, I'd say probably about half. So we're going to go a little bit into the motivations of why serverless matters, in particular why enterprises care, because this thing actually really can make a big difference. Then we'll go right into the meat of things with what is Functions 2.0 and why is it such an important milestone, as well as general best practices. We'll talk through DevOps, security, and some fantastic new stuff along the way. We'll have time for Q&A at the end, so just hold tight for any questions that you have, and of course you can follow Jeff and I afterwards. But let's go ahead and get started with the question, why are we all in this room right now? I think, for the most part, it's because we want to get things done. And the fact of the matter is, serverless is a fantastic tool for doing that, because you really don't have time to waste in terms of delivering your business value. All sorts of organizations are going through digital transformations. Your competitors are doing this too. And you have to be able to keep up somehow. Serverless is a technology where you don't worry about the servers underneath. You're worried about your application. It allows you to focus in a lot more. That allows you to actually experiment more, be more nimble, and actually get your products to market a whole lot faster. And that's everything. There's a lot of great sessions that go into a little bit more around the details of what serverless is, but its core. Don't worry about infrastructure management. Patching, scaling, that's all under the Azure platform. We take care of that. You're not spending time on it. You're not spending money for it. That whole principle of you give us your code, you tell us when you want it to run, and we automatically scale everything up. When you don't have events coming in, we scale you down to 0. You're only paying for the amount of time your code spends running. That's really valuable. We've had customers who've boasted over 100-fold cost reductions. That's not nothing. But I think one of the key things that's driving a lot of folks to the functions as a service model in particular is the fact that it is so productive, because you make up a lot more money just in getting things to market faster. So what do you use this stuff for? Well, frankly, it's a building block, so almost anything. A lot of folks will actually build full applications using serverless, full web mobile backends. We also see folks just adding it in. This is a very common starting point. You go and you build a small monitoring solution or maybe some automation. It's a very common one. And as you start building that in, you see where the productivity gains are, and it slowly spreads throughout an organization. And then all of a sudden you have all these developers that are moving so much faster. And then they might even go and do something like full serverless application. You shouldn't really take our word for it. Conveniently, it sounds like you guys have a couple hundred new friends among you that you can go talk to and actually learn from their experiences as well. But we also have some fantastic customer studies that we've done. Relativity is a e-discovery organization. Basically, the idea is legal, government, investigations and things like that. So they built a monitoring solution. It's actually where they started, just a very small component of their system. They wanted to keep their SaaS offering up and running. And it worked really well for them. I think they boasted something on their initial estimate of maybe an 85% time reduction, which is amazing. Well, other folks in the company started taking note. Hey, that's something we can do too. And it slowly spread. Another favorite of mine is Fujifilm. Fujifilm actually was rebuilding their ImageWorks program, moving entirely to serverless. And what was neat about this one in particular is they ran into a bunch of issues. Not necessarily with serverless in particular, but that's how development goes, right? And one of the things that they highlighted is, look, the fact that we were on serverless meant that we were able to react to those problems a lot faster. And something that would have been, ship blocking or, very, very costly and dramatic for the deadlines was something we could handle. And they managed to get their product into market much faster than expected. So that's the kind of promise that you get with serverless, and that's why it actually makes a big deal. When you're looking at the serverless offerings, you're not actually compromising. You're getting amazing developer productivity, but as we're hoping to convince you throughout this presentation, you're also going to not make any trade-offs in terms of security or DevOps practices. You're going to be able to keep all the things that you want in IT while developers are happy. Both sides get to get what they want, which is really amazing. So when we talk about the serverless platform in Azure, we tend to talk about 3 key services: Event Grid, Functions, and Logic Apps. Event Grid is basically just an event source for Azure. Any service in Azure is going to be able to provide a event through Event Grid, and then a function or logic app can consume it. Functions is what I said before. Give us a piece of code, we'll scale it up as needed. Logic Apps is a orchestration service, basically a visual workflow of integrations. And this is fantastic if you want to actually start pulling together multiple software as a service offerings. So there's actually fantastic sessions on Logic Apps. Today we're going to focus mostly on functions. All of these integrate with all sorts of other Azure services, all of your favorites, and of course it comes with our gold standard around development experiences. So the big news this week is that we have just made generally available Azure Functions 2.0. Yeah, thank you. This is a huge milestone for us because it represents a lot of iteration on that developer experience and all that we can do to make things a little bit easier for you. I think a lot of developers are actually going to see a much bigger improvement moving to 2.0. So what does it mean? Well, the core of it is this principle that your functions can now run pretty much anywhere. It comes from the fact that, so we're an open source platform, and we have this thing called the host runtime. The host is basically the code that ends up running your code. And what's so powerful now is that we've rebuilt this, and it gets delivered in a variety of different ways. So for one, we've got the actual runtime itself being available for our services, but 2, it's made as a Docker image and as part of our core tool CLI, so that when you're actually doing development, you're actually getting the same thing. So we have a whole range of development and hosting options available to you because of the way we deliver this host now. So as I mentioned, development. You can run the exact same runtime on your local machine, and with Functions 2.0, that doesn't have to be Windows. You can run on Mac OS and Linux as well. This is fully integrated with our tool chains. So Visual Studio, VS Code, all of them have built-in support for functions. And of course, if you're using any other favorite editor, you can use our core tool CLI in order to actually get the same thing. Run things locally, set breakpoints, debug, all of it. When we're talking about Azure, we have really 2 modes where we have the Azure Functions service. So there's this serverless mode, more consumption-based, where we're going to go ahead and scale you up infinitely as much as we need to, or scale you back down to 0, and things like that. And that's fantastic. That's where you get that nice cost savings. You can also take the more traditional web hosting model and run it on an app service plan. And that's really nice because it gives you always-on availability and a bunch of other features. Jeff is actually going to talk a lot more about these a bit later. You can also run on a device. You can run functions on a Raspberry Pi. So we have integrations with IoT Edge platform, so you're able to push things down. This is a really cool, exciting new opportunity, and actually changes a lot of the way that you go about developing both for a device and also in terms of how you think about functions. It's a really interesting platform to play with. We also can put those containers on any other fantastic hosts that are available in Azure. We've got tons of great compute offerings in this platform, so feel free to use functions wherever. Of course, we'd love it for you to use the actual Azure Functions service, but by no means are you required. If you're already going to make a commitment on AKS, go ahead. You can feel free to throw functions on there as well. Of course, that means you can also look at non-Azure hosts and, of course, on-prem. So we have full integration there, full Azure Stack support. Basically, this slide is a bit of a distillation of what offerings we have, but we truly believe that functions can really be run anywhere. And what's nice is you get to have the affinity between your development platform is and what's being hosted. Same runtime, available to run now on Linux even for our hosted service. And that way you get a nice affinity if you're developing on Mac OS or Linux as well.
And I won't make my... There we go. Okay, so one of the nice things about this model too is that kind of the two of the appeals of serverless, one managed for me, but the other, it is really nice to program in this functions programming model where now I'm just thinking of what's my event source, I want this to be event driven, here's the code I want you to run an event. what Matthew's just shown here is that you can take that programming model but bring it to whatever platform you might be hosting on. So you can still have the serverless functions programming model even if you are doing it on on-premises Kubernetes or in the AKS service. So this is a really cool way to let you pull that into IoT, into the function service. Wherever you go, this can be that common language between those different applications.
And the really important thing about this point, right, is that the programming model is what drives a lot of that productivity that we saw before. I mean, certainly not having to worry about the infrastructure and having a serverless host is one thing, but just being able to have the functions programming model, I mean, the core of it is you're doing things in an event-driven fashion, and you're focusing on an individual function that has one responsibility. And that really lets you focus in on what the task at hand is. So in terms of language options as well, this is another part where things are changing a little bit, but for the most part, generally available, .NET, so C#, F#, and Node.js. We're also previewing Java. So that's available for you to try out. We'll be hoping to get that to general availability status soon. And at this conference, we're pleased to announce Python support. Now, Python is still in a gated public preview, meaning you have to contact us in order to get access to it, but we'll have information about that at the end. We just want to get a few more things ironed out before we make it fully available publicly. And then, of course, there's many more on the way that we can't talk about today. So you have flexibility of programming language options in addition to all of those different hosting methods that we talked about before. We should also talk about the programming model itself. This is, again, what drives a lot of the value. If you're working with functions, you're often working with different data sources, bindings, and integrations. Our goal is to make it so that you're actually more concerned with the data than the data source itself. If I'm waiting for a blob trigger and an image being uploaded, I want to get the data for that image rather than having to deal with figuring out the storage SDK and going and fetching it and things like that. That's me doing lifting that's not actually delivering value to the organization, right? I only care about the data and what's happening to it as part of my business rules. Previously, all of those were bundled in as part of the core runtime. So you had all of these different bindings kind of put together. In Functions 2.0, we've taken a slightly different approach. HTTP trigger and the timer trigger are baked into the platform, but everything else comes as an extension. And this is really important because they can be versioned independently. That means that as services evolve, as Cosmos DB changes, as it adds different services or changes its SDK, the integration with functions can actually be versioned separately. It can be updated, take all the new things. This also means that we have a lot more control over what dependencies get brought in. So you know exactly what assemblies are being brought in and how they're interacting with your platform. You have full control over the application stack. Most folks probably won't even need this, but it's there if you do. In particular, these programming models, these extensions rather, also give us access to new programming models. Two that I want to highlight today are the Microsoft Graph extensions, which is currently in preview, but that makes it much easier to work with the actual data and insights that live within the Microsoft Graph. And then, of course, there's durable functions. This is something that we've seen actually quite a bit of uptake with in enterprise scenarios because it's a very powerful, expressive model. The idea is, well, that you have an orchestrating function and activity functions that it calls. And this means that you can start doing things like programmatically dispatching functions and actually figuring out how to chain things together without setting up a bunch of queues or fanning out to a bunch of different functions and then waiting for all of them to complete before moving on to the next step. The reason we call it durable functions, though, is because it's reliable and has fault tolerance built in. The orchestrating function has built-in state and checkpointing. And we'll walk through an example really quickly here, but that means that you can actually do long-lived functions that run for actually as long as you need in terms of the orchestration. So let's say I have this orchestration function here, which is just going to do a quick hello world. What happens is that function is going to get woken up, and it's going to check an execution history table for any step that it needs. And it's going to say, hey, have I done this step before? Because I don't know if I'm a new instance of this orchestration or not. This is that fault tolerance. So turns out, no, I haven't done this step before. So that means I need to dispatch work. So the orchestrator can actually go to sleep. It doesn't need to be alive. You don't have to pay for it or anything like that. And then the activity function will wake up, start doing the work that it needs to do. That will get logged into the history table, and then the orchestrator function gets woken up again. This time, when it goes to check the history table, it sees that the activity function actually has done something. So that means I can move on to the next step and then, end in this case. But this is really powerful because it means if that function had gone down at any point in the orchestration, if something had errored out, we would still have this orchestration state to reference, and when we got things working again, it would just pick up where it left off. This is really powerful for a lot of automation scenarios or just general work dispatching. So that's durable functions. There's other places to get a lot more information in depth. I highly actually recommend the documentation around durable. If you just search for durable functions, you'll find a lot of great references and examples there. So anyway, I want to very quickly show how Functions 2.0 actually looks in action. So we're going to go through the quick creation process, and this is also be good for anybody who's not familiar with functions. So we're going to sit here in the Azure portal.
And even if you are familiar, there's some new goodies here too, so
Definitely.
Some stuff you probably haven't seen.
Yep, so this will highlight some of the major changes here. So when I go and create a resource, I'm going to look for serverless function app. And the first thing we'll do is give this thing a name. So if I look here, we have two different options, Windows option and Linux preview. Of course, I have the consumption plan, which we talked about, right, the serverless scaling, and then the app service plan, more traditional web host. We can pick a region. I'll go ahead and do East US. And then this is one of the big changes. We actually have you define the runtime stack. So now you're picking the language that your app is going to be using. You also have a lot more control over the language stack going forward, too. We've revved a lot of the versions. So when we talk about JavaScript support, that's actually Node 8 and Node 10 now. And you can have a lot more control over that going forward. .NET, we're now looking at .NET Core, and so we'll actually look at that here in a second as well. Of course, we have a storage account connection and then application insights. Jeff's going to talk quite a bit more about application insights. Generally, you should always leave this toggle on. So we go ahead and create one. I'm actually not going to wait for that to go through because we have a lot of things to cover here. So I'm going to go to a pre-baked one. And here we have a V2 function application. I'm going to go ahead and take a look at the application settings really quickly because we want to highlight those differences. So our functions extension version is now V2, and we have a worker runtime now, which is .NET. So I've chosen to use the .NET stack. I'll be able to use C# and F# functions. So that's the core of it. Of course, you can also see that in the function app settings as well. But now that I've created this, we want to make sure that we're putting folks on the right path. So when you get started, we're going to try and help you get things set up with source control and things like that. So if I go to actually create a new function, we have a whole set of different development environments for you to choose from. And this is all conditioned on the runtime stack that you chose. So because I have .NET, well, Visual Studio is now an option. For this demo, I'm actually going to go ahead and do VS Code because I am running on macOS here. Continue. And I have a choice between publishing directly or using Deployment Center. Deployment Center, I'll just go ahead and show it to you, is a way for you to actually get all of your CI/CD pipelines set up really effectively. And then once I've made my choices, I get a whole set of instructions for how I get started, get things on my local machine and up and running. And if we complete that, we're actually going to walk through these steps together. When I finish, I'll be going to Deployment Center, which again, Jeff will talk about, but that gives me a whole range of options for how I actually get my code from my local machine up into the cloud. So we'll go ahead and jump down into VS Code now. And I actually already created a functions project. Now, this is an empty project. I don't have any functions in it. If I go ahead and look at how I got here, I went ahead and installed the Azure Functions extension for VS Code. And then that actually enables this Azure node on the left. If I click in, we have Azure Functions available, and there's a create new project. And when you create a project using local tooling, again, you're going to pick your runtime stack because this needs to be a project that's specific to whatever language stack you want to target. We're going to go ahead and create a new function now. I'm going to go ahead and use that project we were just looking at, and I'm going to go ahead and use this classic HTTP trigger. So we'll go ahead and give a few defaults in terms of namespace. I'll go ahead and say that it needs a key when it's hosted in the cloud, and it should go ahead and spin up a new function for me. Now, this is .NET Core, and you can tell because there's a few things that have changed a little bit. One is the fact that we're using the HTTP request object here, but in general, things look pretty familiar for the functions developer. With C# functions, you actually can use attributes instead of the function.json to define the integrations. So in this case, this is the name of the function, but here I have the trigger itself. So I'm accepting GET or POST requests over HTTP. And then we're just processing that. So nothing too fancy here. But you'll notice I'm running on my Mac, and I can actually do my debugging and things like that. So I'm going to go ahead and set a breakpoint. And what we're going to do is we're going to start by running the host locally. So I'm going to go ahead and run the functions host. And this is going to kick off the actual functions runtime, the whole thing. available as part of our toolchain here. So we're going to, on our box, be running Azure Functions. And what we'll see is we'll actually get in the terminal down below a link to that functions that we'll be able to set. Now, I actually do need to attach my debugger here, so we'll go ahead and just do that really quickly. I need to look for func. And what we should see is that this breakpoint becomes active. And then we'll go ahead and we'll try and hit that endpoint, and we should see that, well, we catch the breakpoint and we have access to our locals. So I'm going to jump back over to the terminal and then open this HTTP trigger. Hey, there's a breakpoint. And so I'm able to actually step through and do all of my debugging for a function locally on any platform. And I know exactly how it's going to run in the cloud. Once I'm published into the cloud, I can actually do remote debugging as well. So we've got a lot of flexibility in terms of actually how you get things developed and figure out how things are working on your platform. And so this is a very powerful model for building something that's very cloud native. And of course, when I'm done and have made things work nice and great, I can go ahead and publish. So if I want to, I can go ahead and say, let's see, what was the name of the function app that we did? Let's say it's that one. Go ahead and make that a published target. I'm going to go ahead and all of a sudden things are going to get pushed up. One of the changes that you'll notice here in the terminal is that we've changed a little bit of how some of these functions get deployed. So we've moved to a package-based model where basically all of your code gets zipped up no matter what language you're dealing with, and that gets provided to the function app. This has actually led to a significant performance gain. In general, the Functions 2.0 runtime is a lot faster. It depends on which language and which scenario you're working with, but there are situations where we've seen a 2x increase, mainly on warm path for .NET. But in general, we've seen just a lot of tremendous improvements here. The runtime is a lot leaner, and like I said, you have more control over what goes into it, what assemblies are being loaded, what versions, and things like that. So there's quite a bit of great stuff to find in here, and just in terms of performance benefit. So we just published successfully. So if I jump back over here and look at our function and refresh this page, what I hope to see is that we have our function published, ready to go in the cloud, and of course it would have the read-only version here, but we can grab the URL and start going to town. So very quickly, we've just gone through the core of it. We created a function app. We actually started building a function project locally. We ran it locally and actually set breakpoints, and then we were able to get it up and running in the cloud. So that is the quick lap around Functions 2.0. I realized that was a little fast, and it was also kind of the core basics. If you want to learn more about Functions 2.0, I cannot recommend highly enough a session on Thursday with Fabio and Eduardo. They're going to go into a lot more detail of how Functions 2.0 works. If you're a .NET developer, oh my gosh, there's so much good stuff. We're going to talk about assembly probing. They're going to talk about how you actually debug into our runtime for when things go wrong. So fantastic session. Just promise me if you go afterwards, go up, talk to Eduardo and Fabio. They're great people. Let them know how much you enjoyed Jeff and I's session.
This is a 400-level session, too, so only go to this one if you're ready for 400-level content. If they get any bad reviews from anyone in this room that says it was too advanced, I will hunt you down. Quiet, please. Quiet.
That's Eduardo right there.
That's Eduardo right there. He's trying to get his...
Now, I guess at this point, I've kept him from you long enough. So friends, let me present Jeff Holland, please.
Thanks, Matthew. Great job. So Matthew did an awesome job laying out some of the things we're really excited about with Functions 2.0. And he even showed how quickly it is to get started. I know it went fast, but it's awesome to think in that time live in front of us now, Matthew just published a fully functional and scalable to the nth degree web-based API. Like, that's how quickly he got it up and running. He could now call this thing 10,000 times a second, and it's just going to scale for him automatically. Now, that's really exciting, but sometimes what we forget about and what we don't focus as much about is what about the DevOps part of this? I mean, Ignite is a conference for enterprises. I have given a demo before where I like to do fun demos sometimes. Like at Build a few years ago, I made a demo where I had to get a picture of my boss and tell him what kind of dog he most resembled. I don't recommend doing that for any of your bosses, by the way. But that went great. But afterwards, with some of the demos like that, people are like, that's cool that you can get started really quickly. It's cool that you can have this nice development experience, but what about making sure that this is really production grade? How do I make sure that we don't check bugs into production? How do I keep all those best practices that people like Donovan are always telling me about to rub some DevOps on things? So I want to focus on the DevOps process, and I visualize it often using this concept of inner loop and outer loop. So inner loop is exactly what Matthew just walked through. It's setting up your development environment, it's coding, it's running, it's debugging, it's making sure that everything is working how you want it to on your machine and the app is functional. But just as important as the inner loop is that you need to make sure you have a healthy outer loop. When you have a feature that you finished completing or some work you've done, you need to be checking that into source control so that it's versioned and it's shared correctly with everyone else in your team. As that goes into source control, you should probably be opening pull requests so that people on your team can review that code. And those pull requests and those merges should be using builds and tests automatically that are going to run on that code to make sure that before you push something into any environment, you make sure that all your tests are passing, things seem to be functioning as you expect them to in an automated fashion. Now, once your builds and tests are done, you're going to want to start deployment. More often than not, you're going to have multi-stage deployments. You don't want to go straight from your test directly into production. More often than not, you're going to want to go to a dev environment and a test environment, do some manual testing or some more automated testing and smoke tests before you finally push it out to production. So there's a lot of steps that should happen first to make sure you're not going to break production. Finally, you get to production. You need to make sure you're monitoring that. This monitoring and diagnostic story is extremely important, especially for serverless, because you need to know what issues might be there. What's running slow? What are people having issues with? Where are my exceptions coming from? Which is going to trigger some more inner loop development, and the cycle continues. So what I want to focus on for the next few minutes is what does the outer loop look like for serverless, and what have we done as a team to hopefully make that easier for you? And there's some actually really cool stuff here. So before I go into showing you how you can set this up, let's talk about some of the available tools you have when working with serverless functions. So the first one, which we've seen, you've got your local tools. This is your home for building your function apps, whether it's VS Code or Visual Studio or IntelliJ or Eclipse or whatever. This is really good for obviously writing your function and just quickly validating that things work. You know, you could publish something really quickly, say, oh, this is working in my test app, that's fine. A caution here, though, Damian Brady, one of the developer advocates, has this awesome saying, friends don't let friends right-click publish, okay? Matthew, I noticed before.
Jeff, you let me right-click publish.
I know. There's help for you, buddy, okay? There's a better way, all right? It's only a matter of time before you publish into production. Now, obviously, if you're doing it for a quick test, whatever. I publish directly from Visual Studio all the time, but not into production, okay? Don't right-click publish into production. And a tip Matthew mentioned as well, most of our tools will do this automatically for you, but if you ever get a prompt to run from a package or run from a zip, always turn that on. He mentioned we now bundle your package up as a single zip artifact, and it gives you a bunch of performance improvements. So that's your tip for that tool. Now, we also talked some about this deployment center. This is powered by a magical engine behind the scenes of functions called Kudu. It's not very important that you know that, but I mention it in case you're already familiar with it. This is nice because it's fully integrated with app services and functions, and it gives you really quick CI and CD. This is really nice if you just want to quickly wire up an app that you've built to some source control that you already have. Like I've got some samples in my GitHub repo. Some of them are like JavaScript. Some of them are C#. Anybody could go into this deployment center and say, hey, I want to deploy this app in Jeff's GitHub, and everything will just hook up for you automatically. You could choose to auto-update that app when I update my code, or you could just do a one-time clone. Either one works fine. However, do be aware this is a really quick and easy method, but it's not as customizable as something like Azure DevOps. I don't have the options to customize as easily that build process. I don't have the options to customize deploying to multiple stages. So this is nice for getting stuff quickly cloned and selected from source control, whether it's GitHub or DevOps or whatever else. But it's not the biggest, baddest way to do this. And we do have some new UX around it, though, too, to help make it easier. And Matthew showed some of the flavors of that today. Now we have our wonderful used to be called Visual Studio Team Services, now called Azure DevOps. This is fully managed CI/CD platform. This has everything that you need. This is perfect for production scenarios, okay? When we work with large enterprises who are doing things on functions, more often than not, they're using Azure DevOps to help drive that process. I would give a caution here. Well, I guess there's actually two cautions. One of them's not listed. This does require a little bit more configuration. Like, this isn't just a one-click and you're done thing. You're probably going to want to go customize your build process, make sure your tests are working, customize your deployment stages. It's not super complicated. They have a beautiful UX, but it is something you need to make sure you have some cycles for. The other caution I'll give you, historically, Azure DevOps and most CI/CD packages rely on a technology called web deploy to get your bits out to your function. That still works. It usually generally only works for .NET applications, but it still does work. However, if you want to take advantage of this run from package feature, the best thing you can actually do is build your function in a way that you're building a zip file that's not a web deploy package, and then you're using run from zip in the VST or the Azure DevOps experience. And I'll show you that in a second. There's some documentation. I actually just wrote some blogs around this, but just throwing it out as a caution. And there's a cool tip here, actually. When you're releasing to different stages, like let's say I've tested my function, I want it to go to dev, and now I want to go to the production environment. Before it goes into production, I probably want to run some few last-minute tests just to make sure that nothing's blown up and nothing's on fire. Azure DevOps has this concept called release gates. And actually, in the Azure DevOps experience, you can set up so a release gate could either be like someone manually goes through and says, cool, deploy to the next environment, or you can do automated tasks. And those automated tasks could actually be other functions. So you can use your functions to test your functions before the functions go out into your functions, which is really convenient and easy to say. So you can do that, though, and that's kind of fun to say, like, hey, before you push this to prod, run this function that's going to call these 3 endpoints, make sure they give me the response I'm expecting, and if my function says we're cool, then go to the next environment. So a little bit of inception there. And then, of course, it is worth mentioning, you can use other CI/CD products. So if you're using Travis, if you're using Jenkins or Octopus Deploy, that's totally fine. Everything still works for you just great. In fact, with Jenkins, we actually have a custom extension for some of our Java functions. So this is great if you have a business or an enterprise that's already made significant investments in another platform for CI/CD. You can still party on and have your functions have all these best practices there too. I would caution you in some that the documentation for some of these other ones are more limited, which is something we'll work on over time. Hopefully we'll have good docs for Octopus, good docs for Jenkins moving forward, but it's a caution. And again, same idea. Try to use that run from package gesture, which we've got docs on, instead of just doing traditional web deploy. But usually it's the same Azure published things. And the only I guess other tip I'll give you, generally, from a DevOps perspective, if it works for Azure App Services, which has been around for a very long time, and there are a lot of docs around, it will also work for Azure Functions. So if you're ever struggling to know how to set something up and you can't find anything for functions, it would probably work just the same with App Services. So let me show you what some of this looks like right now. So I am here in Visual Studio. And I'll go ahead and just create a new project so you can see quickly what that experience is like. So we'll create a new Azure Functions project. I'm going to leave it as the version 2 runtime, which is now GA. I could choose any of these kind of templates right here. There's even more once I create my function. And let's say I go ahead. This is just like what Matthew had in his Visual Studio code, but mine's in Visual Studio. Same idea, breakpoints, run. Very cool and rich environment. Now the question comes, this is now working great on my machine. How do I start to build that outer loop stuff that I just talked about? Well, it's actually a lot easier than you even might realize. So you watched me create this project from scratch right here. I can actually right-click my solution, and directly here inside of Visual Studio is this nice button that says Configure Continuous Delivery to Azure. And if I click that button, Visual Studio is actually smart enough that it is going to look at my solution, realize the project type that I have, and automatically go set up for me an Azure pipeline inside of Azure DevOps. So you'll see right here, hopefully you can see, it's recognized that this is, in fact, a Azure function app, and it's going to use the consumption plan by default. It's going to say I'm going to need a storage account. It's asking me where I want my dev environment to be. And in this case, it's actually saying, hey, the first thing you need to do is add this to some source control, because that's the first part of that outer loop. And since I haven't done that step, it's not letting me do more. But I could even just follow this wizard, add it to source control, whether I want it to be, this should be renamed to DevOps, but that's fine. It probably has if I update my Visual Studio or GitHub. And now I can just follow this wizard. And automatically, at this point, Visual Studio is going to take my project that's checked into source control and build for me a full pipeline. So let me show you what that pipeline looks like. It looks just like this. This is one I deployed a little bit earlier. I did make one small change here, and I'll make this a call out in case anyone goes to their hotel room tonight and tries this out. Right now, the template the Visual Studio gives you actually starts at this step: NuGet restore, build, test, publish, publish. Because we're using .NET Core 2.1 right now, you actually are going to want to update your NuGet tools, or else you're going to get a bunch of weird things. It doesn't have to be 4.0, but anything newer than 4.3. So we're getting that fixed. Hopefully it will roll out in the next week. But you might need to add this step if you're using the new V2 to update your NuGet version as well. But then everything else works. And I could go back into my solution, add unit tests, and test my function as well. In fact, there's another blog post I've been writing around writing unit tests for your functions, so you can check that out. So now this is totally going to build. All these builds are going to work great. And I can then have my release pipeline. And the default pipeline that it sets up for me is pretty basic, but I can always go and customize it as well. So here's one that I've customized a little bit. All of these environments are just one simple job, like one task that I have to do. And that task is deploy a function app with the app service action. So there's a built-in action. It's called deploy to app services. I renamed mine here to deploy to function app. I'll click the add button and show you the one. Right here, it's not in this one. Deploy. App service deploy, right here. I know it says app service, but you'll notice it says function apps right there. Okay, that's it. I just have to use this action, and now I can deploy this to whatever environment, whatever settings I want. I could come down here and to say, here's the app settings for this environment. I could even make some other customization as well. So that's a feel for how quickly you can get started. You can then customize this. And now if I was to go into my project, make a change, check that into source control, it's going to automatically run. All right, so let me do a few more because I know not everyone here is writing in .NET. In fact, actually, maybe I'll get a raise of hands. How many of you here are interested or are using functions that are JavaScript? By raise of hands, anyone? Okay, a few. And then Java? Any Java? Okay, a few Java. So for those here and for any who might be watching the recording, let me show you a few more examples. So one, this is a similar example, but I'm actually using the .NET CLI directly to build and package my solution. So it's just an example that you don't have to use the .NET framework steps. But I also have an example here of a Node application. And I have samples for all of this too. So here's what a Node build pipeline would look like. And we don't yet have that right-click gesture for Node, but this is what it would look like. So I'm going to specify my Node version. This could be Node 8 or Node 10, depending on the flavor I want it to. Now, I do have some steps here that I do want to call out, because this is required if you're using something that's not HTTP, and this is a little bit advanced. If you remember back when Matthew was talking about 2.0, one of the big changes we wanted to make is we wanted your triggers and extensions to other services to be extensions to the host. We want to make our core host as lightweight and as flexible as possible. And that means that our core host doesn't always know how to talk to things like Cosmos DB. It doesn't always know how to talk to things like Azure Storage or Microsoft Graph. You need to pull those things into your project. Now, the good news is we have tooling like the Azure Functions core tools in Visual Studio that will look at your project and do this for you automatically. But it also means if I'm automatically building my project, I need to add in that smarts as well. So these are the 3 steps for non.NET languages that I need to add if I'm building a function that's not just HTTP. All right? So the first one, I'm going to make sure I have .NET Core, because that's what the tools are going to rely on. I'm going to install the Azure Functions core tools. I'm doing that through npm. You can see here I'm just saying npm install Azure Functions core tools. And then I'm going to run a command using those core tools I just installed that says go install all my extensions. Okay? So I do need those 3 steps. And when I now say install my extensions for this build, it's going to go pull down all the integrations that I need. And then I can continue on with the general Node pipeline. So I'm going to install my Node packages. I'm going to run any test. I usually write my function unit test in Mocha, but you could do whatever you want. And I'm just saying, hey, npm test here. I'm going to create my archive and then publish that archive here. So this is what a node build pipeline would look like. And then just quickly, I'll show you one more, which is Java. And so Java is very similar to Node, only instead of using npm. So I still have those first 2 steps. I'm going to make sure I have .NET Core and install the core tools. But for Java, I'm using Maven instead, because all of our Java tooling is built off of Maven. And I'm just going to say Maven package. And I'll mention this briefly. Maven actually has the smarts to go install extensions for you, so I don't have to explicitly install them here. And then I create my archive. And then it's the same publish pipeline, regardless, but this is the build pipeline. So I know a little bit advanced, but I wanted to show it off. The use.NET Core? Yeah. It's a built-in task. This is the .NET Core tool installer, and I just make sure I have at least .NET 1 here. This is actually the latest version from the website, but anything newer than .NET 2.1. And the reason that you need .NET Core, I might have mentioned this, is to install and build the extensions. We actually rely on the .NET SDK today, at least, point in time, hopefully. So the only other cool thing I'll show you is when I build this out with things like Visual Studio Team Services, I can actually trigger, like, hey, what's going to start this build process? And I actually have the options to say things like, I want to trigger whenever there's a pull request or whenever I merge something into a specific branch. And so that's actually what I've set up here for some of these test samples. This is on GitHub. I actually have an example of functions written in C#, Java, and JavaScript that include unit tests. But if I came in here to like my C# function, and I decide that I want to make a change, all it does is detect whether a number is odd or even. It's not super advanced. But maybe I'm like, you know what, I'm feeling super odd, so I'm going to say, regardless if the number is odd or even, I'm going to say it's odd. And let's say I think I'm super cool, so I'm going to do that, and I'm going to be like, everything is odd now, suckers. Okay? Because I'm using best practices, I'm actually going to create a pull request. Now, what's awesome here, just by doing those steps that I showed, whether it's from Visual Studio or not, once I create this pull request, whether it's through Azure DevOps or through GitHub in this case, you'll notice here in just a second, I actually have a build that's automatically going to kick off. It's going to run through all of my tests. I do have tests that check odd numbers and even numbers. I'm not going to wait for it, but if I waited here for a minute or two, we'd actually see that this is going to fail and give me a big red X on this pull request and say, hey, this breaks the build. So this is just an example of how, yes, this is a serverless function. Yes, this is really short lines of code, but that doesn't mean I need to sacrifice my best inner loop and outer loop practices. I can still bring all of that in here as well. So I think those are the main points I want to call out, so we can switch back to the deck now, and we'll move on to other parts. And then I can answer questions on this, too, when we get to the Q&A part in just a few minutes. OK, so coming back here to that inner loop, outer loop, we've talked a lot about how to get this into source control, how you can do automated builds and tests, how you can do publishing through different stages. Now it's finally in production, and here's where monitoring comes in. We need to make sure that we have a real-time observability into how our functions are performing and to how they're scaling. Monitoring in serverless is different in some ways than traditional monitoring, because I'm not going to send like a ping and be like, is this server up or not, because it's serverless. So I really just need to be looking at the behavior of those functions and seeing if when they're running, issues are happening. So Application Insights is the service we integrate very richly with to provide some incredible monitoring experiences. Honestly, this is such a powerful tool, and they can do it so much better than we can, that we just work very close with that team. We meet with them very often. We say, hey, let's make this a great experience. And so that's exactly what we've done. So Matthew showed you when you create a function, you're always asked to create App Insights with it. Please do. It's a really good practice. This is going to let you analyze all your traces, all of your executions, see when things are running, how long they're taking, any exceptions that are being thrown. It's going to log all of that for you, and it's extremely fast to query. If you saw yesterday during Scott's tech keynote, there's the Data Explorer service, and they analyze like billions of records in a second. That's the same service that's powering App Insights behind the scenes. So it's incredibly powerful to query. And one of the new things we're excited to announce and show today is that we actually integrate now with AppMap, which is a feature from Application Insights that allows you to analyze the dependencies of your application and view the health of those. So let me show that quickly for you here. So I have a scenario. We've got a fictional store, and they have an online checkout process. And that entire online checkout process is powered by functions and service bus queues. Now, how it works is that somebody, like a customer, says, hey, I want to buy these gloves. And we're going to go ahead and drop something in a queue and call a function. And the first function is going to check to make sure we have the right inventory. And assuming it gets an answer, it's going to drop something in a second queue. And then another function is going to pick that up and check or create a shipping notice, and then charge the customer, and a third function, and so on and so forth. Obviously, you could use frameworks like durable functions here to orchestrate, but let's just assume we have queues in kind of a microservices architecture. And one of the challenges here is that this pipeline is obviously really important. This is how we make money. This is how we ship our goods to customers. So we want to make sure we're observing the health of this. But it can be really difficult in a serverless world, traditionally across the entire industry, to keep track of all of these functions that might be interacting with each other. So let me show you here what AppMap can actually do for us. This is really cool. So I have this exact solution running here in my subscription. So I'm going to open up my Application Insights instance. Let me zoom in a little bit. And right here in Application Insights, I've hooked all of these functions up to this instance of App Insights. So I'll go ahead now and click this AppMap feature. And what's awesome here is in a very logical and understandable way, as this loads up, let me switch to this view. Here is my function process. So each of these green circles is a different app, but AppMap has actually been able to analyze and correlate my traces so that I can see very logically how data is flowing through my system. I can see that first I have this check inventory step. I can see that usually calls the function calculate shipping function. That's going to make an outbound call to this external API down here, and also have this other function execute through Service Bus. I have my queues up here, and then finally I have my send confirmation email. So this is nice for me. Now I get kind of this single view into how my solution is behaving. And if I want to drill into details, like you might notice here, I have some red. I have some 8% failures on my process payment function. So let's click in here to investigate this a little bit. And App Insights gives me all of these really helpful guides. And let's try to figure out why we have so many failures. I have over 1,000 failures. So let's click Investigate Failures. And I can see here that the exception I get the most is this application exception, right over here. Oh, that didn't zoom in very far. That's fine. I have this application exception. So I'm going to click this and say, hey, let's investigate. What's this application exception? Again, App Insights is like, hey, you know what? You actually saw this exception yesterday. This is probably a good one to investigate. But I have more examples here of different instances where this has popped up. Let's just follow this recommendation and keep, thank you for defining executed, Mac. I appreciate it. So I've gone ahead and say, yeah, let's investigate this specific instance of the exception. So now it's going and it's figuring out, okay, let's go into our logs right now and look at this specific exception and tell you what happened. Now what's awesome here, this exception happened in the func process payment function. So that was the name of my function app. But Application Insights is actually smart enough that it has correlated this entire message through the pipeline. So I could trace what happened when it called this function, check inventory, then it called service bus, then calc shipping picked it up and did something, then it called service bus, and then finally you hit func process payment, and here's where you hit your exception, and here's some details about the exception you hit. So I can actually go reverse trace this through all of the corresponding functions that this message passed through with AppMap. So this is really powerful to follow the trail of an end-to-end message throughout my entire serverless application. So the other thing I'll show you just quickly here in AppMap, if we go back to our, it's always so hard for me to navigate when I zoom out so much. If we go back to the AppMap, you can notice here some of the other dependencies. So I have some API calls that this is making. I could see here, hey, I need to call this Azure Website API. This could be an App Services API. It could be another function app. But I can also investigate the health of these. I can say, oh, look, I can see these are the two operations I'm calling. This is the average latency that we're seeing. I'm getting a bunch of 404s. Maybe I can go investigate those, and so on and so forth. So all of the dependencies, all of the flow of data is easily trackable with this AppMap feature. And I think in a bit, Matthew will actually show you some more features of App Insight. So with that, let's pass it over. Oh, actually, I'll do these very quickly because I want to make sure we have enough time. Best practices, we've covered these. Write unit tests. This is a just tip right here. So in different environments, you're going to have different settings. You might call different URLs if it's in production, or a different URL if it's in development. Environment variables are your local.settings.json file when writing locally, or your application settings when writing in the cloud. So just remember that. Every function should be checked into source control. Use pull requests to add new features. Deploy to stages. Don't right-click to production. We do have a feature called slots, which is in preview today. This is fine for HTTP scenarios. The only gotcha that I'll give you, and the reason it's still in preview, is because we don't pre-scale your slot before we swap. So if you have a lot of traffic in your production slot and it's scaled out to like 50 nodes, and you swap to your dev slot, you're going to go from 50 nodes to 0 nodes, and you're going to have to let that scale up over a few seconds. So we're figuring that out, but it works fine as long as you're aware of that caveat today, and obviously enable App Insights. So Matthew, we're running shorter on time, but we still have time on security. This is a good section.
Yeah, that's fine. We always have time for security, right?
We do.
So.
It's never the last thing we think about.
Yeah, we always go right here first, right? So, of course, this is an enterprise session, so you saw this coming, right? Whenever you start talking about security, I feel like you always end up with this shared responsibility model. And the idea here is just that the cloud provider is responsible for certain things, the customer is responsible for others. So if you're on premises, well, congratulations, you are responsible for everything relating to security. Then if you're using software as a service, the vendor is responsible for most of it, but you still have some responsibility, right? You care about that data and things like that. It's when we get into the development space where we start to come across like a little bit more variety in the spectrum. I mean, infrastructure as a service helps. It gets us part of the way there, but there's still quite a bit. Platform as a service does better, but still not a cure-all, right? We still have quite a bit. The question is, what happens when we start moving a little bit further down the platform as a service spectrum and into serverless? Well, frankly, not a whole lot of change. You're really focusing on that change in the logical application server. And that's not a bad thing, right? By choosing serverless, you're already making a really strong security posture for your organization. But there's still going to be things that you have to do. And of course, some of the things that might have been responsibilities before that you may not have cared about as much come to the forefront. You're dealing with a different set of scale and a slightly different take on some of the same problems. So security can be dry. Let's play a game. Please spot the vulnerability in my code. I am writing a GitHub webhook. I'm going to be a good open source citizen, and whenever somebody submits a pull request, I'm going to thank them for their contribution as a comment. The problem is that I've been a very bad person. I've put my credentials in my source code, and none of us would ever do this, I know. We would typically put things in application settings, and everything would be fine. But better is for us to use something like a centralized secrets management repository where we can really lock down the access. So we'll use something like Azure Key Vault. So revising my code, I'm going to get the event from GitHub, fine. And then I'm going to actually use Azure Active Directory to get an identity for my app. This is how I'm going to go talk into Key Vault. Now, I'm using managed identities here, which means I didn't have to use a bootstrapping credential. I barely had to write any code. I just had to say, give me a token to Key Vault. We'll talk a bit more about this later. Then I can actually use Key Vault SDK. I can go ahead and fetch a secret from the vault. So now I have this one place where I'm going, and it's permissions-based. So Key Vault knows about my application, and it says, hey, yeah, you can access the secret. And then I can actually assign my header and then go call GitHub properly. So now, not only have we moved things out of source control, but we've also moved them into a place where we can really manage what policies are in place, when that thing gets rotated, and all of those good things. The problem with serverless is, well, okay, I have a lot more credentials to manage, and some of them I don't have access to that code, right? That code that I just wrote is really handy, except when I'm using those binding extensions that we talked about earlier, because that's code that we, the Azure platform, provide. So we don't go talk to your Key Vault there. I'm pleased to say that we're going to be introducing a story where application settings themselves can be backed by Key Vault. So traditionally, an application setting, you just set it as part of your app config, and it has all the permissions that your app typically has in terms of management. When we start up your app, we actually put that into environment variables. And that's fine, because then my code can just reference that environment variable, and it's happy. It's a little different with this model. Instead now, I'm going to have a reference to something that lives in Key Vault. And so Key Vault is the actual source of where my secret lives. Again, who can access it, what policies are in place. When we go and start up your application, we're actually going to go call into Key Vault, use that managed identity for you, and fetch the secret. It still gets injected in as an environment variable, so your code doesn't have to change. So as soon as this rolls out, you're all going to go move everything into Key Vault, right? Because now we get secrets out of our app settings. We have central management, and that means that things that were being used by those bindings and triggers, the connection strings to our queues and all that good stuff, our application's insights key, that can be moved out. I'm going to show you what that looks like. I do not have a live environment that is currently working. This is under development. It's coming soon. But I can show you a quick video of what this looks like. So we're going to go ahead and, there we go. I'm going to go and take a look at application settings for an application that I already have. I'm going to go ahead and see that I have an application insights instrumentation key. That's something I want to protect. So I'm going to go ahead and copy that out, and we're going to migrate it over into Key Vault. Now, the next thing I need to do is actually give my application an identity in Azure Active Directory. Oh, that sounds really hard, right? Conveniently, it's actually a single click. I'm going to turn on Managed Identities, click Save. We're going to wait for that to provision, so there is a little bit of magic happening behind the scenes. The general idea, and we'll talk through a little bit more of the details later, is that we're going to actually provision a service principal in your Azure Active Directory. You do not need to manage this principal. There's nothing for you to rotate. There is nothing for you to worry about managing. The platform will take care of all the refreshes and everything around it. Your code can reference it using some of the protocols, which we saw a little bit of code that actually made use of this identity. But the platform can use it too. So now I'm going to go into Key Vault, and then I'm going to create a new secret. And I'm going to paste in that application insights key that we had before. And so I'm just going to call this thing AI key. That's the name of the secret. Doesn't really matter as long as that's something intelligible for other users. And then when I create it, it's actually going to have created a version. And this is important because we don't have necessarily the full rotation story ironed out quite yet. So when we first release this feature, it's probably going to require you to have an explicit version. So when you do rotate secrets, you're being conscious about which one you actually want to use. The rotation is something that will be hopefully soon after that. But the actual secret has a URL, which we copied out. We can see that I actually already had access to the application, which is why I was able to create a secret in the first place. If you're working with production, you typically don't want to have a human user who has multiple permissions to your Key Vault. Hopefully you're using your DevOps pipeline to automate that. And then you want to give an access policy to the application. So I'm actually just going to search the application by name, and it's going to find that managed identity that I provisioned earlier. So now we have something that we can reference in the same way that we reference human users. And I'm just going to give it only the Git permission, because all this application needs is the ability to read that one secret. Right? I don't need it to list other secrets. I definitely don't need it to start creating them or updating them. So always remember to click Save on your access policies. This is something I see way too many people mess up, and then they're asking, wait, why can't I access Key Vault? So then we're going to jump back to our function app, and we're going to establish that reference using that URL that we just grabbed. So I'm going to go into application settings again. I'll go down to where I have that application insights instrumentation key defined, and we're going to start making this reference. This syntax is subject to change. We're still ironing some things out, not final by any stretch. But we're going to say that it's Key Vault, and then we're going to give it a secret URI, paste in that value. There's going to be other ways to construct this as well. Again, very much preview. So we've got that value in. You can see it's got the actual vault information, the secret, and the version explicitly. So this is something that, again, preview, not quite ready for y'all to use yet, but hopefully very, very soon. So go ahead and save that. It's actually going to get the platform set up. So now all of a sudden, we've just got that reference. And we can probably see there's another connection string. I'm probably going to move that as well. But for now, we have one less secret in our platform, or sorry, in the application itself. But it's still available. And so when I go and grab the URL of this function, I'm going to create some load, and we're going to see that working in App Insights in real time. So I jump over to the Monitor tab. And we can see things are connected. I have Application Insights ready. My instance is there. Don't have some data there, but if I go over and check into the live metrics stream, I can actually see all the events coming off of these requests. So it takes a minute to just connect, get everything nice and set up for real time, but now we've got actually a live tracker. So I'm going to go in, and I'm just going to mash the refresh key a few times because I want to generate a few requests. So once we have those requests in, we can actually start seeing them come up live in App Insights. So all of a sudden, there's no application insights instrumentation key anymore. It's all in Key Vault. So we've managed to lock down a secret, but still have our application take a strong dependency on it. That's very powerful because you definitely want to start moving things to Key Vault. This is something we hear from organizations all the time. I think it was the #1 customer ask on Azure Functions for a long time. So this is something we'll be closing out very soon. Now, the underpinning of this is managed identities. And the quick lap around that is we're going to provision some credentials in AAD. You don't have to worry about them. The only way your code interacts with them is through a token service. You ask for a token, we give you a token. And then that token gets used for calling into other Azure services. Key Vault is definitely one. If you're looking at automation scenarios, look for the Azure Resource Manager. It works with anything that supports AAD. There's a whole list of services in Azure now that are using AAD, including storage is now in preview. Service Bus has direct integration, as does SQL. You need to be worried about your permissions, though, because if you start giving them too loosely, you're going to run into problems. Let's say I have a couple things in a function app, and a function app is really just a container of functions that need to share some config or code or things like that. But if you're sharing config and permissions, well, let's say I have readers and writers. Well, they both need permissions to read and write. Okay, now my reader has permission to write. That may not be what I want. So the better approach typically is to split things into multiple function apps. You're not paying anything extra when you're doing the consumption plan, right? Because it's only a matter when the function is actually running. But this lets me separate things nicely, make sure that I have permissions assigned, and I'm giving least privilege, right? What is the lowest amount of permissions that a given function needs? This is also nice because a function app is also a unit of deployment, so we can tie it back into some of that DevOps pipelines we had before and do a microservice style approach, right? So one part of the application can be updated without interfering with any other part. Let's play the game again. What's wrong with this architecture diagram? I'm not going to let you go too long because I cheated. It's everything. It's also all the connections in between. And the reason I make this point is just that you can't think of individual pieces, right? I think we have a very tendency to zone in. But when you're talking security, you do have to take a little bit more of a holistic view. Because, well, let's take a look at this code, all right? What's the problem here? I'd argue that it's this target here. I'm taking our HTTP request and then throwing it onto a message queue. Well, that seems innocent enough, right? Well, what's downstream of that queue? Oh, it's an injection attack. Huh. So maybe I should have, I mean, this code is bad, right? We should be validating our inputs and things like that. Like, no question here. But especially if you're dealing with a distributed architecture and microservices and like large team, how do you know that that's not happening downstream of you? There's this notion of validating your outputs, right? Yes, I should be defending against injection attacks. I should be doing all these good things and validating my inputs, but I also need to know that I'm sending decent data to the rest of my system. In the same vein, I also need to, we talked about permissions and things like that. So I need to check incoming things, right? Log in users, things like that. But I also need to know that I'm giving the right permissions to Key Vault or other resources and make sure that I'm honoring that least privilege, right? The other thing is we talk a lot about serverless scale, right? So I get a bunch of requests and my function scales out. And then what about the things that I'm calling with all that scale? Well, here's one of my favorite anti-patterns from actually back in my days in mobile. Somebody would write something that sends a push notification because we've made a decision that it's time to send a push notification. It goes down to devices, and that's great. And that device is going to call back into my system, and everything's going to work great. And it's going to scale so well because I can send notifications to all sorts of devices. And then that works great because I can call into functions, and function scales great. And then my function calls a SQL database. And all of my functions call a SQL database. And my SQL database doesn't like that very much. And this is, quite literally a self-DDoS. These are the types of things you have to be conscious of as you're building out some of these systems, especially when you're dealing with connections like this. We have best practices around doing, pulling your connections within a function app and things like that so that you don't run into this issue as much. It's still something that's very common, though. So, security. You still need to do all the same things that you would do for platform as a service, traditional web app development. You don't get away from those. There's also a slight difference here because you don't have a logical application server. So all of your favorite security tooling, not all of it will translate over. Doesn't always apply. And so there are a bunch of new vendors out there who are making really good strides here. Snyk and PureSec are fantastic solutions that actually let you do some extra monitoring of serverless applications. You have more secrets now because you have more connections, right? And in general, we want to be moving our secrets under management. This is very important now because there's just more of them. We also have to deal with all the permissions that make up those connections. I mean, it's one thing to have those secrets, but it's also, if we can use our managed identity to actually link things together, right? Get rid of the secret entirely, even better. And then, you have to be mindful of both inputs and outputs because it's not just one part of a system, right? You don't have a monolithic application. You have all these little components, and those components need to talk to each other and be good citizens of your overall solution. Now, I didn't get to talk a bunch about networking, And that's because, well, Jeff, do you want us to show them?
Sure, let's do it. All right, thank you, Matthew. That's awesome. I love that security content. I think it's super important and super helpful. So for the last few minutes here, I actually want to talk a little bit about hosting and connectivity and also share with you some announcements of some things we haven't shared publicly before. So thank you for staying. So for the part to kind of preface this, I want to focus, if you remember back to when Matthew brought this up, we actually have two kind of flavors in the Azure Function service to host your function app. One of them is that consumption plan. That's where you only pay for what you use, will scale out really rapidly and infinitely. And then the other is the app service plan hosted model. Now, I actually want to drill deeper into both of those. So here's a comparison between the two. So consumption has some really cool things about it. It scales really rapidly and proactively. We actually look at the event source and we say, hey, the rate of events coming in is very high, so we're going to scale out before it even hits the CPU downstream. It also has unbounded scale out. You can scale out really, really wide, further than you can with most any other service in this consumption plan. However, there are some limitations. There is no VNet connectivity available today. You're limited to a 10-minute execution limit, so you can't run anything for a very long time. The instances that we use, we just pull what's available. These are small instances, a single core, 1.5 GB of memory on one of those instances that we use for your function. But it can scale to 0, which is nice from a billing point of view, but it can be nasty, because if you call a function that's been active for a while, we have to provision a new instance for you, which adds some extra latency called cold start. So the other idea is that, hey, there's this app service plan, and it has some really cool things about it, almost starting from the bottom. It's always on. You've reserved some instances for you. This will never go cold, so you have 0 cold start in an app service plan. You can also get really high-end hardware. You can get multiple cores, a ton of memory for one of these instances. And because you're reserving this hardware, you can run it on as long as you want to on these things. There's no execution limit. And you can have VNet connectivity. You can have these functions in an app service plan talk to your VNet. However, there are some problems today that make it challenging for some enterprises. One is that app service plans are limited in how far they can scale out. A standard app service plan can only go out to 10 nodes. Which means if you have a lot of traffic and you expect you need more than 10 nodes, you're stuck. It only scales out that far. One of the other biggest challenges with app service plans is it's built for web hosting, so it doesn't really do distributed density as well as consumption plan, but also it relies on autoscale, which is a reactive scaling service that will look and say, like, hey, I'm going to wait for the CPU to be above 70% for 5 minutes, and then I'll know I need to scale out. But for serverless workloads, that's often too slow. And so people are like, hey, I like the good start of consumption, but it's hard with app service plan. So I'm excited to announce today a new flavor of hosting that we're going to start offering soon. It's available today in private preview. And this is the Azure Functions Premium Plan. And you can think of this as a premium plan specifically geared towards enterprises who want the best of both worlds. So this will give you the rapid, proactive scaling of your consumption plan. We will look at your event source and we will scale you out to new nodes just as quickly as we do in consumption. And you'll be able to scale out as far as you can in consumption too. You're not going to hit those plan limits that you hit with app service plan today. Now these functions can talk within your VNet. They can have connectivity to on-premises resources or within your VNet in Azure. You can run functions on them for as long as you want. You can choose premium hardware, multiple cores, a ton of memory. And these things will at least always be on so that you won't hit cold start. So that's the plan that we're going to start offering. We have a link here in just a slide, just to show a really quick demo of this, and then we can do some Q&A. So I have on my screen, I won't even show you some of the stuff. I've written a function. This is based on a real scenario that I've worked with where I have a blob container in Azure Storage, and it's got a bunch of files on it, and I need to go encrypt all of those files. Now, I have that same function hosted right now in the Azure Functions Premium Plan and also in the Consumption Plan. I have called neither of these in the last 20 minutes because I've been presenting. And what I'm going to do is I'm going to call the premium one, and I'm going to call the consumption one. Now, the premium one is always on. This thing has 4 cores on every instance. It can also scale very, very quickly. And you'll actually notice it's already done, it looks like. The premium one, because it was able to parallelize this work across multiple instances, it took 3 seconds to execute. And executing that same workload in my consumption worker, just by the fact that it's got a little bit less beefy hardware, there was a little bit of cold start in there too, that took 7.5 seconds. So in half of the time, I was able to go and encrypt about 50 different files just by changing the hosting model and choosing that I wanted some of these premium instances there. So that's something that we're working on now. We're making available to you in private preview. Anybody can sign up for this, and we'll start to give you access. The pricing is a little bit different. Well, you're paying for cores and memory, and you do need to make sure that you have at least one core reserved at all times for you, because we need to keep one core hot. So there is no $0 a month pricing. You can pay as little as one core a month, though. All right? OK, so that's that. So I already did that demo. So some takeaways and next actions, and then we'll do some Q&A at the microphones. Functions 2.0 generally available yesterday. We didn't add the link for private preview. Talk to me for the private preview link for Python or come to our booth. Use DevOps. I have the test samples for all the different languages in GitHub. Serverless security, best practices Matthew had, as well as keep an eye out for that Key Vault feature rolling out very soon. And if you're interested in signing up for the Premium Functions private preview, you can do that today by going to aka.ms/functionspremium, and we'll get you onboarded if you're interested in potentially using serverless with some of those premium plan benefits. So before we go into Q&A, I'll jump here, because I know some people are heading out to get to other sessions. Please fill out your evaluations. Matthew and I love coming to conferences like at Ignite. And not only does it help us improve as speakers, but it helps the conference understand which sessions are valuable or not. So please provide honest feedback. Let us know what you loved, what you didn't love. It will both help us as we improve for future sessions and also help make sure that we get slots at other conferences if things go well. Yeah, here's some of the other sessions coming up, so we'll keep this up. And then if you have any questions, just make your way to a microphone so that others watching the recording can hear the question.
If you are interested in the Python piece, the session on Thursday with Asaveri is going to be a fantastic overview of that, and she'll definitely have all the details for signing up for that as well.
Yep, perfect. OK, I'm looking at the mics. I don't see anyone lining up for any questions, so we might be OK. So for those who want to
Did we do that well? Oh, there we are.
Oh, here we go. Go for it.
Hey, this is more around the application insights. When you had your, it treed your call stack basically for your exception, are you able to see any of the input and output parameters? And your function was called process payment, and I don't know if you know where I'm going with that.
Oh, yeah, so
information.
Yep, we will only trace in application insights what you explicitly trace in your code. So we don't log inputs and outputs unless you add a log this thing. So like, I'm not going to log the credit card. I'm not going to log other things. So we won't log things without asking you first what you want to log.
Question.
Yep.
There.
Yeah, other side of the room, go for it. Oh, is it not working? You can shout it, and we'll repeat it.
The Key Vault only can host only up to 16 managed service identity. So one of my customers was complaining about cannot add more than 16 managed service identity. How can I figure that out?
That's an excellent question, which I probably need to refer to the Key Vault team.
What was the question?
So the question was around the actual number of, was it access policies that you were concerned with in terms of Key Vault configuration?
Yeah, so the kind of access policy.
Right. So there's a limit in terms of the access policies themselves. That is something that I would need to talk to the Key Vault team about in specific. I wasn't actually aware of that limitation myself, so I will follow up for sure.
As a quick one, back in the past, your environment emulators and runtimes had to be installed separately. Does in the 2.0, are these getting baked in to where they're coming in as updates and not an external piece that you have to download and install? Like a Azure Function runtime used to be a separate installation. So
you still, with the VS Code and tooling or Visual Studio tooling, you would still need to make sure that you have up to date the core tools. Okay. So that is still sort of separately versioned. The extension does for for Visual Studio does handle that as part of some of its updates, but the VS Code extension does not bundle it, I believe.
That's right. But the core tools bundles with the runtime itself,
yes.
with the host runtime. So it's just one install. Visual Studio, because of the paradigms that they have, will pull it in for you automatically and update it. Visual Studio Code will guide you to pulling it in and updating it, but you just need to make sure you have the functions core tools, which will include the host runtime.
Exactly. Yep.
Good question. We'll go up front here.
For those that are not so familiar with kind of the development aspect of it, What would you recommend from a knowledge perspective to get oneself up to speed with being able to create and manage and create projects within Azure Functions?
Sure, I'll give it a shot. So there is a few guided quick starts on Azure.com. One specifically that's good for beginners is there is a quick start on building a serverless website. It actually uses a bunch of serverless components, but it's like step by step, which is really nice. We've got a few of those workshops and self-guided labs on Docs.
I would actually check out the new Microsoft Learn content. There's an entire section on serverless, and I think it awards something like 700 XP if you're going for all those awards and badges. But that's a really good place too, because that'll get you started from nuts and bolts, building your first serverless application. It'll go quite actually in depth over time.
Thanks.
Yep.
One back there?
And there is the only other one too. There's a bunch of content online. Like this was a 300 session, but there's 100 and 200 level sessions on like Channel 9 that covered the whole gamut of like just learning to more advanced stuff.
I would say a couple of the sessions later in the week are also really good references. The Wednesday session with Gorka should hopefully be a good kind of lap around some of those architectures as well. Also, for use cases is also really good. I think that's going to be a good session as well. So we had 1, 2, 3, I think it was. So start right there.
On the security topic,
Yeah.
so you mentioned that additional security tooling is needed. A lot of the traditional security tools aren't available in serverless.
Right.
If you are a security team, what do you do in the meantime, sort of?
Yeah, I mean, a lot of it is, I think, still evolving. The serverless space is still pretty young, actually, and the community has been having a lot of conversations about this. I mean, if you go to any like dedicated serverless conference, the main topics you're going to hear people talk about are observability, and then like what do we do about like security best practices. There's a whole massive startup scene around this. I mentioned a couple of providers, so there are some tooling options available, but in terms of, I mean, you're dealing with smaller distributed applications. How you get those policies enforced is really important. So you can drive consistent security guidelines. It's honestly a really tricky conversation. I mean, that's why I love services like Key Vault, because once you start making that super easy, your developers won't fight it, right? Because they will actually have, it's very straightforward for them to integrate, and you have complete control over who can deal with that. You have complete management. So a lot of it is about making it, incentive alignment. You want to make it, we're trying to make it as easy as possible for people to do the right things. But it is something that's definitely evolving.
The Azure Functions Premium VNet connectivity, is that similar to like the apps, how the app service plan, where it does like a point-to-site VPN connection?
Yes, but even on that, and I believe later in the week, whenever Christina's session is, there's improvements to the app service VNet connectivity coming that the premium plan will also get to. So it won't just be point-to-site.
You will have full site-to-site. Some of the things that were previously only available to app service environment are going to be available to app service plans, including premium functions.
Okay, so you said they're gonna. Is it gonna be site-to-site or not?
Yes, I don't know if she's already announced it, so that's why I hesitate.
I just asked because we've had some, we've had to spit up some isolated AS.
Yeah, right. Yeah.
That
So
should not be
definitely-
necessary here.
There's some issues with express route and point-to-site.
Yeah, so there are improvements coming there. Yeah, you can swing by our booth too if you need.
Yeah, check out the app service sessions as well. If you go by the app service booth, which is right next to the functions booth, we'll get you sorted there.
Gotta get out.
One last question, and then we'll be wrapping up, start unpacking. Go ahead.
Your demos were both on Visual Studio 2017 and...
Or his was VS Code, but yes.
Yeah. Do you have the same level of tooling in VS for Mac?
It's there, but it's a little behind. So it's got 75% of everything there in VS for Mac, but it's catching its way up. So for now, if you're just starting, if there's something VS for Mac can't do, VS Code definitely can, but it's getting there. It's just taking a little bit longer. Okay, all right, so we are getting kicked out, so we got to run. But we will both be at the booth a bunch today as well at the Expo Center, so feel free to stop by the booth and ask us more questions there as well. Thanks, everyone, so much.